Welcome to another episode of Code for Thought. The eScience Center is the Dutch National Center for Research Software Engineering, and if you're wondering what the E stands for, it means enhanced, as in enhanced science, and for good reason, because software and digital data, as we know, are indeed enhancing science and research. The center is an independent organization and located in the Science Park on the outskirts of Amsterdam. It started its work in 2012. And since then, the center has been able to establish quite a reputation not only in the Netherlands, but also internationally. And perhaps you have already come across some of the areas the eScience Center has been contributing to. For instance, in November 2022, when they ran an international funders workshop together with the Research Software Alliance. Then there is the citation file format they've been working on, and they also created a research software directory platform which they've made available to other research centers, like for instance the Helmholtz Association in Germany. I already covered some of their work in previous episodes. In this one, I want to focus on what life at the eScience Center actually looks like. Who are the people working there? What made them join, and what kind of projects are they working on? There are about 100 research software engineers at the eScience Center, and I met with 3 of them. The first one you'll be meeting is Luisa Orozco.
My name is Luisa Orozco, and I'm a research software engineer, and I have been working at the Netherlands eScience Center for a little bit longer than 2 years now. And I'm part of one of the sections that focuses on natural sciences and engineering. Myself, I have a background in civil engineering, specifically geotechnics, but also in physics and software matter. During my PhD and my research career, I have been working with software, so specifically doing simulations of granular materials. This requires a lot of computation power and are quite complex data in the end what you get, so you have to post-process using several techniques. So along my career, I have written a lot of software, and nowadays I have this title, or I'm in this position of a research software engineer, in which I work with researchers to do software for research.
Okay, next we have Mano Locascio.
My name is Romano. Originally, I'm Italian. I have a background in energy engineering. I did a PhD in Italy in technical physics. You may know it as applied thermodynamics. And after a while, I moved to Switzerland for 3 years for a postdoc at EPFL. And then finally, I started the position at the eScience Center. Now I'm a research software engineer there. I'm working under the umbrella of the ACFAR team, which is focusing on the energy system integration.
And finally, meet Jura Smits.
My name is Jura Smits. I'm a research software engineer at the Netherlands eScience Center. What I do is I make software for research, and I work mainly in the healthcare domain. I started in 2020, which was a little tough because it was like the second day of the lockdowns. That was something to get used to. I worked in industry before as like software engineer, data scientist, data engineer, all those kind of things. So yeah, I did that a couple of years, and then I started working at the eScience Center.
3 different people, 3 different and international backgrounds, and 3 different areas they focus on in their daily work. We're going to find out more about their work in a bit, but first I wanted to know what attracted them to the eScience Center in the first place. So let's get back to Louisa again. So did you move to the Netherlands specifically for taking up the role at the eScience Center, or were you in the Netherlands already?
So I did my PhD in France, and then I was doing a postdoc in Belgium. But because my boyfriend lives in the Netherlands, I wanted to move to the Netherlands. And then I found this position at the Netherlands eScience Center that fitted my profile.
Okay, Louisa was gradually inching her way to the eScience Center from France over Belgium. But what about Mano? It's no less interesting because he made his way from Italy over Switzerland. So let's hear from him then. So what made you actually go to the Netherlands? Because you've gone from Italy to Switzerland and then to Amsterdam.
Well, first of all, the need good work first.
Yeah.
But no, there were different opportunities here and there. So I have to say, when I saw the position at the eScience, I was there first for another position, which was very interesting, and that's why I decided just to relocate. There was the job on one side, but also the city was very attractive for me. I love Amsterdam, so I feel very comfortable here. So these two things maybe were pushing me to make this change.
Well, Jura didn't have to move countries, but she started in very challenging times, notably in the middle of the pandemic. But that wasn't the only challenge she had to face, as you will hear in the following clip. I think the 2020 period is quite interesting because it's obviously when the pandemic started. And I do remember at the time where I was working, we hired people, but we couldn't meet them, of course, because we were in lockdown.
Yeah.
And for anybody who started, it was a little bit weird. So how was it for you then, starting in the middle of a lockdown and starting in the middle of a pandemic?
Yeah, it was quite difficult for me. Also because I came from like an industry background as a software developer, that kind of stuff where the task for me, what I'm supposed to do is quite clear. Then I became a research software engineer and it's not as clear as what you're supposed to do because you kind of have to find your own way. So we collaborate with researchers. It's a collaboration. They have some problem that needs to be solved or some research that they want to do. And we kind of have to find a solution together. So for me, it was in the beginning quite tricky because it's normal to not to write a lot of code in the beginning of projects. I was not really used to that you need to have this time for this creative process of like figuring out what you're supposed to do. It felt kind of unproductive, even though it's all part of the work. Yeah, and I also kind of found out that I'm quite extroverted. So sitting at home
Really?
was not really the way I want to do my work. I like to go to the office. But yeah, I tried to find my way around that. So I really became the social person at the eScience Center.
What Jura said about the pandemic, I can certainly sympathize with. It was indeed a shock to the system, not just for me, but for many of us, even though it now seems a long time ago. And although I appreciate that a number of people missed the office, to be perfectly frank, I really didn't and enjoyed working from home, but that's for another day. Moving on now. I already mentioned that all three of our guests, Louisa, Amano and Jura, work in different areas. So here's my chat with Louisa about what kind of projects she's involved with and how the engineers actually work at the eScience Center. So what is it you actually do directly at the eScience Center at the moment?
So our main goal at the eScience Center is to enhance or to improve the use of computing software and computing resources and digital technologies in academic research. To do that, we actually go two ways. The first one is that we collaborate with researchers in projects where we design better software or sustainable software. The other way is through teaching our workshops on digital skills that go from very basic digital skills like basic software development to more advanced like designing GPU kernels and how to do GPU computing.
Oh, right, okay, well, that's quite a wide range. So could you describe, perhaps in more detail, one of the projects that you're doing? I think you've been involved, I'm reading this now from my script, I'm sorry if I have to remember. It's a chemistry project.
Yes, so the way in which we work is that the researchers that have an idea write a proposal that goes through an evaluation process, but if they get granted, they will get in-kind support. So in this case, some computational chemists from the University of Amsterdam applied to a small-scale initiative of machine learning, in which the main goal is to bring machine learning tools to researchers that are not completely familiar with these kind of tools. Specifically in this proposal, the researchers have heard a lot, and we have all heard in the media that there is ChatGPT, that there is something like Midjourney and DALI, that you can, for example, put a text, a sentence describing, for example, an image, And then these models would generate an image that fits the text that you prompt. These chemists were also intrigued or interested on whether we could apply that for chemistry. So whether we could generate materials using the same techniques. They wrote this proposal in which we were using stable diffusion models to generate crystals.
Okay. You mentioned that it generates images. So is it then generating images or kind of 3D models of crystals? Is that the idea of it?
Yes, so you may have heard, for example, Midjourney or DALI. In that case, they generate images. So those are pixels, and then you have the color of each one of the pixels. For the kind of crystals that we are generating, the model is going to start from noise. Noise is like random values of the positions and the types of the atoms. And then iteratively is going to start correcting the positions of each one of the atoms and the types of each one of the atoms until in the end you get a crystal that should be something that is feasible or realistic in the chemistry space.
Is that for teaching purposes or is that for research?
So nowadays, like big tech companies that are working on AI are tackling these kind of problems because they wonder whether these generative models could be used to generate new materials and so discover new materials.
All right, okay.
So this is why the chemists are intrigued on whether it could be used and whether what is generated is actually chemically sound or if it's just a random positioning of atoms. What we wanted to do in this project is to explore how these two works, how these methods work, how easy or how difficult it is to make it work, and also to generate some materials that would be an easy entry point for researchers or students that want to get familiar with these kind of methods, such that they can plug and play already directly in the code and get a visualization of what the model is able to generate.
Okay, so we heard from Louisa what she works on, and it quite frankly sounds very interesting, but let's turn to Mano, who's been working in a very different field. What we're going to talk about now, which is in fact the project that you're involved with, which I think is, and I'm reading this out now, it's optimization framework for the energy network. Is that correct?
Yeah, to be more in general, is let's say a software that allows you to run simulation for any kind of energy system you can imagine. You don't have only the electricity network, you can model whatever you want. And you can also explore the interactions between all layers, all the vectors and sectors eventually. So it's a very flexible tool. It's managed and created by this Finnish partner, and we are contributing to this framework on different sides. So personally, I'm working on a specific side related to the graphical user interface of the software.
So when we talk about the energy network, so you said that it's not only for electricity, say it can be adapted to anything else. What does it actually do? Could you describe the system as a whole a little bit more detail?
You have to imagine it's a very flexible tool that in principle allows you to set up your workflow. It's called workflow. The workflow is, we can say, is the set of the boundary conditions that are describing your problem, your circumstance that you want to simulate and model. So you can model, for instance, the energy production of a certain factory, and you can see how this is distributed through the network. And you can even try to optimize the size of the network, or the size of the components of the energy systems, and so on. In the end, you comes up with an optimized configuration of the system you have in mind.
Let's say you have a power station that creates a certain amount of watts.
Yes.
So you can then simulate how this is being distributed through a network to, the end user. Is that how we can visualize it?
Yeah, you can simulate the generation, so you're modeling the system, but you can also optimize the system, which means, let's say you want to know which is the optimal size of this power station.
Right.
So you have different power stations, so you can produce the electricity with different possible combinations. So you want to know, okay, which is the best combination, for instance, to produce that amount of electricity at that given time. So you can run scenarios and do assessment in that sense.
Finally, let's hear from Jura. She already mentioned earlier that she's focusing on the health sector, and here she talks about her projects in more detail. So let's go into the project. So you mentioned healthcare projects. Could
Yes.
you give us an example of what it is you're doing?
Yeah, so one of the projects that I started when I started at the eScience Center that I'm still working on is called the Carrier Project, and it's about preventing cardiovascular disease. There's two components to this project. The first one is to find which are the factors that really contribute to a risk of cardiovascular disease.
Mm-hmm.
And the second component is coaching people that have a high risk. So once you found these factors, you can try to find people that have these high risk factors and to coach these people to get a better lifestyle using an e-coach. Personally, I'm more involved in like the first part, so this analysis of finding these factors. And in this case, we want to combine both medical and socioeconomic factors. So we want to connect healthcare data to socioeconomic data. Because this data is held at different locations and is very privacy sensitive, we are working with techniques from like federated learning to connect this data to be able to make analyses based on this data that is actually physically separated from each other.
Let's stay with Jura's project for just a little bit longer. Not least because the use of machine learning applications in healthcare interests me personally, but also to give you a flavor of the kind of engineering problems the staff at the eScience Center face and how they go about dealing with them. So here's Jura again. Healthcare has been employing artificial intelligence actually for a while, I believe, or at least in test cases or in test applications. But there are challenges. That's what I wanted to ask you. There are challenges when handling data in healthcare applications.
Yeah.
And I wanted to get from you what these challenges are and what it is that a software engineer can do to make that safe for patients and useful for researchers.
Yeah, with healthcare data, you're working with very sensitive data, right? It's personal data, it's data about people, and it's also about, it can be about health conditions. So that is data that needs to be very well protected. One way to protect it in our case is using this federated learning, this technology. So it's a technical way to protect the data where the data is not sent to another site. So the data owner stays in control of this data. So it's not like there's copies sent around and at some point you don't know where all these copies are. No, the data stays at the place the data comes from, so at the hospital or at the Dutch Census organization. So if a researcher wanted to do an analysis, this analysis is actually sent to these locations and only an aggregation comes back. Before that, of course, there's other certain steps that need to be taken, like anonymization or pseudonymization. So that are things that you have to do. Yeah, the solution is not only technical. For example, there's two people in our project that actually have a contract with the Dutch Census Organization, CBS. So there's also like legal documents in place, legal agreements in place. In case there's a leak, there's a procedure that you can do. Yeah, that you need to follow, right? And also with data, especially with like rare diseases or like if you have a lot of variables, it's anonymization is not always enough. There might always be a combination of variables that people can identify someone.
Yes.
So one way to solve this is with federated learning, but also in our case, it's only a limited amount of people that actually have access to this data. It's not like, oh, we anonymize it, we present this data now to the public. No, it's only some researchers that have contracts, they're part of this legal procedure. Only they have access to this data. So there's like layers upon layers, like both technical, legal, and practical solutions that actually stack on top of each other to keep the data safe.
I'm quite interested in this federated aspect where you leave the data on site, say in a hospital or in a clinic, but that means that your application or whatever it is that you're building needs to be able to connect to all of these. that I imagine can be quite complex, and
Mhm.
to manage the network connections, make sure that it all works. So how do you manage all of that?
So there was already an open source software framework there when we started this project. So we joined this open source project. The software is called Vantage 6. It's been developed by the Dutch Comprehensive Cancer Registry
Hmm.
because they do their own research and they want to connect data, cancer data from different places, from hospitals, but also from abroad. They've done some research where they did a combined analysis on data from, for example, the Netherlands and Taiwan to kind of see how things are different. So this is an open source software project that we connected to, and there were certain features that we kind of needed for our specific use case. That is something that we added to this software.
You didn't have to build that from scratch,
No,
basically. So
exactly.
you're already, okay, well, that's good. So the anonymization of data is also something that I find quite interesting because, as you rightly say, stripping the name and the date of birth and maybe the address away sounds safe enough. But if you have a rare disease and there are only, I don't know, 5 people in your city that have that, it might be actually quite easy to detect who that is and where they
Yeah.
live. So the extra measure that you're putting into place is then only certain people can access the data. So in case anything happens, then you can trace where the data went and who had access to them. Is that the idea?
Yes, exactly. There is these people that are accessing the data. They have signed certain contracts. I don't know about these legal details, but I know
Mm.
that the Dutch Census Organization has a lot of this in place. Also, when you work with the Dutch census data in the normal sense, there's always a check. If you do an analysis and you want to take this analysis out of this system, it's the microdata
Mm.
environment, there's actually a human being that checks if it doesn't leak any private information. But it's also, the caveats are different per analysis, right? Because the one solution that will work for everything is to not share any data at all. That is the one thing that will work.
Except for the researchers.
Except for the researchers, yeah, we do want this healthcare research. Like also patients, a lot of patients, especially so when they get a disease, they get health problems, they are also more open to their data being shared, or sometimes they're already assuming their data is shared, even though it's not the case. You really need to understand the data, I think, to know what are the risks.
Well, there's a lot of interesting stuff in there, but let's leave AI in medicine and the handling of healthcare data for now. And in the final and next section, I want to focus on another aspect of work at the eScience Center. That is, how the engineers interact with the researchers and how they handle their workload. As a National Centre of Research Software Engineering, the eScience Centre in Amsterdam covers a wide range of different research applications. Louisa, for example, is working on applications in chemistry and natural science, Jura in healthcare, and Amano in the energy sector. Which means you need to be able to work with different researchers, different requirements, and, at times, different working cultures. Even more so as engineers at the centre work in general on several projects at the same time. Which is what Louisa brought up when we talked about her workload and how she manages it. Is there still time to write any code?
Every research software engineer at the Netherlands eScience Center has multiple projects that ranges from 2 to 6 projects, depending on your preferences.
Oh, wow. Okay. 2 is difficult enough, but 6 is really quite amazing. Okay, go on. Sorry, I interrupted.
No, indeed, it's quite challenging if you have multiple projects at the same time.
Mm.
But also, that means that you're not working on a single thing at the same time. You can actually translate things from one project to another one. Yeah, sometimes it happens that you are blocked because you're waiting for data or because you're waiting for some collaborators to decide on something. So it's nice to have multiple projects at the same time.
And how much software development do you actually still do? Because it sounds a little bit more like you're managing projects. And we come to that maybe a little bit later. But are you still involved in the hands-on work of software development?
Myself, yes, I am actually writing a lot of code, but also doing a lot of research because due to my background, I have a vein for research. I do a lot of literature review, a lot of prototyping, but also developing a specific functionality for big software. It depends a lot on the project. There are some that are more oriented toward research and prototyping some ideas, and there are others in which we come to directly collaborate with a group that has a well-established software and that requires some improvement or bring some features to the next level.
So you do actually do quite a lot of development still. That's great to hear. So could you describe what a typical day in your work life looks like?
That's a good question because I do many different things. A group of things, I call them like focus sessions. I have these blocks in which, for example, I used to write code. So I have to focus for that and have like 2-3 hours to just do that. I also write papers. I do a lot of literature review and also writing some grant proposals. I do this in my focus sessions. I also participate in a lot of sprints. So at the eScience Center, we have sprints. For example, if there is something that needs to be developed, sometimes we run a sprint, an entire day or several consecutive days in which an entire team works hands-on together on developing something. We do this also for code review and also to work and develop on training materials.
Right.
Also, part of my job is a lot of meetings. I meet with the project partners to discuss advancements, how are we progressing on the project, but also with the special interest groups that we have at the eScience Center, in which we basically share knowledge about the technologies within the center.
That makes my head spin. So because that's quite a lot. I do remember from my position at UCL, a University College in London, that we were looking after 2, sometimes 3 projects. And I always struggled with keeping on top of that because you have to do a lot of context switching. So how is that working for you and how do you keep on top of all of that?
That keeps me alive.
I'm sure it does.
It's still interesting. I think if I would have to code like the 8 hours of a day, I wouldn't be able to. I like that I can do different things. The ways in which we cope for looking after so many projects and managing the content switching, I rely a lot on GitHub.
All right. In what sense?
For example, we have issues, and then we track issues, and we work also with Kanban boards that are also integrated within the projects of GitHub.
Yeah.
Then you know where you are on completing some tasks, and what is next. Where were you like 2 weeks ago? Also, at the eScience Center, every project has a project log. So we have some internal notes. This goes hand in hand with the program manager. So we have program managers per section that are actually in charge of all the project portfolio of the section. So in my case, the natural sciences and engineering. I work together with this program manager. I give regular updates and I maintain this project log updated. With this, we kind of expect to cope with the possibility, for example, if something happens to me and I have to quit the project, someone else can pick up my work.
Some projects actually consist of different research centers and research groups working together, and not only from the Netherlands, but across different countries. Take Emmanuel's project, for example. He already mentioned earlier that he works with partners located in Finland, and here he talks a bit more about how the work is organized. So the application itself, you mentioned Finland or a Finnish partner.
Yes.
And how many other partners are there involved?
If I remember it correctly, we are 14 partners from the Netherlands, of course, Belgium, Finland, the PI. There is an Italian partner, Irish partner, and many European partners are contributing to the project.
Okay, it's a really pan-European project.
It's an Horizon project.
So how does the project work itself work? How does the interaction with all these 14 different partners
First
work?
of all, you have to think that there is a contract behind, so there is a clear project, all the work packages that we have to deliver. Of course, there is a lot of collaboration between the partners, so certain work packages requires a strong involvement of 2 parties, for instance, but everyone knows what other people are doing, so there is a strong synchronization effort in that sense. We meet frequently, sometimes also in person when it's possible. We have a clear vision of what we have to deliver when we have to deliver. So in that sense, I see that is a very well coordinated machine. Otherwise, you miss the final aim of the project.
Still try to imagine how this works in practice because you have 14 different partners. So I think it's quite difficult, I would imagine, or maybe time consuming to get everybody on board. So you come up with a different proof of concepts. Are they then being presented to all these 14 different partners, or is there kind of a subgroup that says, okay, we're going to look at this?
There's a subgroup of different people. Internally, we try to figure out whether what we are proposing makes sense or not. And then after that, when we are fine with the final solution, we propose outside to the community. So there we gather the real feedbacks from the outside.
What Amano describes is quite a structured approach to keep so many different partner organizations from different countries and organizations together. Still, working with many different people requires a lot of non-technical skills, be that how you communicate with other researchers and teams, how you share your work, how you organize and manage different projects, the workload, and. These skills are often, and I believe mistakenly, called soft skills. Mistakenly because in my experience, there really isn't anything soft about them. I asked Louisa how staff at the eScience Center get support for all these skills. So part of the work is to talk to researchers and to keep in touch with all the other colleagues that are working on the same project or on the different projects. That requires a lot of soft skills. So how are you being trained up for this, and how is that working for you? And is there a way that research software engineers can be better equipped in order to face that? Because it sometimes requires some diplomatic efforts to talk to scientists and researchers, doesn't it?
Yeah, indeed. This is really important, and I think it's a very important part of the job. One of the things that we do have is a special interest group on soft skills at the eScience Center, where we talk about these kind of things with other colleagues. People share their experiences, and then we learn from each other. We have also some personal development budget. So I have followed some project management courses, communication style coaches. Let me repeat that. With my personal development budget, I also follow some project management courses and some communication style coaching and courses.
Okay, I hope Louisa, Jura and Amano gave you a bit of a flavour of what work at the eScience Center in Amsterdam looks like. Some of it may sound familiar, like managing several projects at the same time, context switching between management tasks and coding, and working closely with different researchers in different teams. It's a unique work environment that can be very exciting for sure, but also at times difficult. I wonder if this is what our guests actually expected when they started. I asked Jura to find out. You've been working there since 2020, so that's now 4 years. Is that the kind of role that you expected to have?
Yeah, not at all, actually. I have a background in artificial intelligence. So I was not necessarily aiming to work on healthcare, but I think I kind of found my way here. Yeah. Before I joined the eScience Center, I hadn't heard of federated learning at all. I was expecting maybe to do more conventional machine learning at the eScience Center. Yeah, but I think I found my way here, and also like kind of my network. I think it's also the social aspect. I enjoy working together with IKNL. I developed this Vantage 6 software. Yeah, it worked out for me. But yeah, I didn't expect it.
And with that, we've come to the end of this episode about the eScience Center in Amsterdam now. I had the pleasure of actually going there earlier in 2024 on occasion of the first National Research Software Day the team at the center organized. But if you'd like to find out more about the work of the eScience Center, take a look at their website. You'll find the link in the episode notes. They also have a fellowship program, in case you're wondering. Applications for the current cohort are closed, but if you're interested, keep watching their websites for future programs. And as always at the end, if you have comments, suggestions, or anything else you'd like to share, get in touch via LinkedIn, Mastodon, Slack, Matrix, or good old-fashioned email. And if you would like to support the show, go to my Patreon page. Finally, I'd like to thank the eScience Centre and in particular, of course, Louisa, Jura and Amano for their time and patience. It's been fun meeting with you and all the others of the centre in Amsterdam. Keep up the good work and thanks for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.